Well, hi, my name is Mark Barnes. I'm the Vice President of Reliability Services for Descase Corporation, and we're excited to be part of the Asset Condition Management Conference for this year. We're looking forward to being down in Florida in March. I'm going to be presenting on one of the days on cradle-to-grave lubrication management, and we're excited to have you at the event. So this first session is going to be on what we refer to as cradle-to-grave lubrication management, and the use of the word lubrication in the title is by design. A lot of folks think about lubrication in terms of the similarly related word lubricant. And when we talk about lubricants and lubrication, they actually mean two very different things. The lubricant is the thing that we actually put into the machine. It's the oil or the grease that we would use for lubricating the asset. But lubrication really refers to something much, much more than just the product. Lubrication is the act by which we store and handle and dispense and apply that lubricant, keep it in the machine, and make sure that that lubricant is in good condition throughout its life. If it's a grease lubricated asset, how do we re-grease it? How often should we re-grease it? What grease should we use? And all these things really are very important when it comes to how lubrication contributes to overall equipment reliability. And what we find is that companies that have done a good job on lubricating their assets and have a good lubrication program have a significant advantage in terms of maintenance cost, equipment reliability, and avoidance of downtime. Those that haven't focused on lubrication typically will have a much higher cost of maintenance, anywhere from 5 to 15% of maintenance costs can be lost due to the impact of poor lubrication. They have much higher rates of downtime and issues related to equipment reliability. So in this session, we're going to talk about lubrication and lubrication management specifically. And when we talk about lubrication management is really every step that a lubricant takes as it travels through the plant. So once we've selected the manufacturer and the brand and the type of lubricant we're going to use for each application, the job doesn't stop there. We need to think about how we're going to store the lubricant, what's the most beneficial way to do that based on how much lubricant we're going to use and the amount that we dispense at any given time, and how we're going to actually get it into the machine. That factors into handling and dispensing and how we can actually transfer oils from A to B without creating problems. Once we're at the machine site, how do we get it inside the machine? So that could be re-greasing bearings, it could be topping off oil on a gearbox, it could be changing oil on a hydraulic system. And then once that oil is in the machine, making sure that that lubricant remains in good health, make sure it's clean, make sure it's dry, and that it's fit for service. And what we find is that typically with lubrication, 60 to 80% of problems are actually directly related to an inability to keep lubricants clean. So we'll focus on that a little bit. And then we'll talk about the final piece of the puzzle, which is oil sampling and oil analysis, and how do we use that type of technology to validate that the lubrication process is on track. The use of the chain as a graphic is really symptomatic of what this presentation is going to be all about, because we all know that a chain is only as strong as its weakest link. So a lot of companies focus in on one area. They have, for example, a good oil analysis program, or they have a good lubricant storeroom. But if you don't focus holistically across all the different facets of lubrication management, then the good work that you may do in one area is offset by something that may happen in a different area. So we're going to look at all three basic areas of lubrication: storage and handling, application, and in-service, and talk through the simple things that we can do to improve lubrication management throughout the plant and to make sure that we stay on track. We'll also focus on the machine itself. So we'll talk about how the lubricant should be applied and how it should be maintained in the asset, and how we define what I like to refer to as a lubrication policy. The lubrication policy is very simple. It is how is the lubricant and the lubrication process managed for a specific machine, whether it's a class of centrifugal pump, whether it's a type of gearbox, whether it's a type of hydraulic system, compressor, so on and so forth. And it encompasses all facets. So how do we actually ensure that we can do best practice lubrication PMs? How can we make sure that we can check that the lubricant is in good condition? If we want to take an oil sample, how can we make sure that we can adequately sample? Is the machine set up for best practice? It's very easy to define how to how to perform best practice, but not so easy to do if the machine is not properly configured. So in this session, we'll talk through all the aspects of how we manage lubricants through cradle to grave, and then we'll focus in specifically on how to make sure that the health of the lubricant in the machine remains as it should, and that we obtain optimum reliability for our equipment. So we hope you can participate in the event and look forward to seeing you at the ACM conference. One of the presentations we're going to be making at the conference will be on visual inspections and indeed visual oil analysis. And most folks have heard of obviously oil analysis and understand to some extent the value of oil analysis. But for most people, oil analysis is really about just taking an oil sample in a 4-ounce bottle, sending it off to a commercial oil analysis lab, and waiting patiently 24 or 48 hours or perhaps as long as a week to get the data back, either electronically or in paper format, and finding out if their oil is in good condition, if the lubricant is needing to be changed, if the machining's starting to wear, is the fluid contaminated with any particles or moisture or other contaminants. And certainly that's a very important part of condition management. It's a very important part of predictive maintenance. But for us, we like to think about oil analysis a little bit more broad-ranging than just physically taking an oil sample and sending it off for analysis. We like to think about inspections as part of the overall oil analysis program. Anytime that you're in front of a machine and you're looking at a sight glass or an inspection port, or you're making some kind of observation, that in my mind is oil analysis. It's covering data to try and get information about what's going on at the machine site. So in this session, what we're going to be talking about is how to do very, very basic inspections, how to look at machines and to determine if the lubricant is still healthy, if we have the correct amount of lubricant, simple things to look for when we're at the machine site. Most of us are used to looking at level gauges or sight glasses, but maybe there's some things that you haven't really thought about in terms of how we can best identify issues at the plant. The reality is that this is, if we want to use a football analogy, this is blocking and tackling. Some of the more elaborate technologies we have, like vibration analysis and mainstream oil analysis, thermography, and so on. This is like the star quarterback or the wide receiver. They're the stars. They have the big shining lights by their name. But the reality is that the basic fundamentals is about blocking and tackling like we have in football. If we don't have a good offensive line that can protect that quarterback, that star wide receiver doesn't have enough time to get down the field, and we don't have success and we don't win the game. So visual inspections and visual oil analysis is that basic blocking and tackling. It's making sure that basic things like lack of lubricant or heavy gross contamination or other issues don't happen in the plant. So we'll talk a little bit about how we can use tools to identify problems within the machine, what we should be looking for, how to set up and configure our machine to allow us to do visual oil analysis, and some of the simple tools and techniques that we have available to help us diagnose some very, very basic problems. And again, this is not an intent to replace some of the other technologies, but really just to supplement and augment our ability to identify problems in an early stage of their inception. So we hope you can join us for this presentation, and we look forward to seeing you at the ACM conference in March.